Hi everyone, today we're going to be looking at the Productivity 1000 PLC to Stride Field I/O Modbus TCP. Now, detailed information contained in the video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there will be links to the description below that will start you at video 1. There will be links to the rest of the videos in the series as well. So the Productivity Series of PLCs can use remote I inputs and outputs from Stride. And the Stride Field I/O modules are simple and compact. And they provide economical means of connecting inputs and outputs to an Ethernet Modbus TCP communication network. Now, every module operates as a standalone Modbus TCP server and can be configured via the web server. And previously we did that, and you'll see the links in that in the description below. So the first thing we'll do is take a look at our modules that we will be communicating with our Productivity 1000. And the first one will be the Stride SIO-MB12 CDR. And that is actually a discrete combination module. It's a 8-point input, 12 to 24 volt DC syncing, and an output 4-point relay. It's a Form C, so it's a single pole double throw relay, and there's 2 amps per point that you can do. Now the Ethernet is an RJ45 connector, or port on there, and it is, like we said before, a Modbus TCP server. And what we're doing is we're going to take the our output that we have, and we're going to feed that back into our input here. And this is in and then we have a 24 volt power supply to supply this voltage here. So my plus voltage comes in this connector here at BS0, and it's brown wire right here, and that brown wire also comes up and goes to the common of my relay, and then my normally open comes back down and goes into my input side for my input side. So that's my plus member, so that's why I'm sourcing the input to this module. And then my common of that goes back to my 0 volt DC. So that is my wiring. So as I turn on the first output, or first relay output, then the first input will actually turn on. Next, what I have is we have a potentiometer going into a SIO-MB04ADS, which is a 4-point current and voltage 16-bit isolated input current signal input. So what we're doing is we're going to use our input analog tester using a 9-volt battery, and we are going to put that into our input side of our module, our Stride Remote I/O. And there's the pin assignments that we've assigned for that to actually put that in. Remember, this is a 16-bit analog input. So then, once we have that done, now what we're going to do is we'll look at the way we configure these modules. And if I look at my Stride, there we go. And what we do is we call up our web browser, and our web browser, we're going to use the same IP addresses we did last time, which is 192.168.1.131, and we'll type in our username, ACC, and our password was ACCA. We'll log that in, and you can see here, first thing that comes up with our network settings. And you can see here, this is our combination. My system configuration is next. So it tells me I need a watchdog enabled. And a watchdog, what it will do is trigger a bit every time that we have we've lost communication for more than 3 seconds. And then if that's a watchdog I operated, you can see I turn these 2 indication buttons on. or the flags that are turned on to indicate that I've lost my communication to that module. Also, there's a power up event, so every time the module powers up, I can detect that within the my communication and determine what to do with that in my program. There's software update. There's a username and password if we want to change that. We have my digital inputs and the current status. We can read those, and there we go. You can read, and we can see here that input 1 is on right now, and my digital outputs, and I can see my outputs, one's on too. So that is how I configure my my Stride SIO-MB12 CDR. Now on my analog, again, the password's the same. And we notice that we've just changed the address to 132. We'll log in. And there we go. And what you see is our network settings. The same thing. We have our system configuration, in which again we're using a watchdog enabled for a timeout of 3 seconds. Our software update, username and password, and then our analog input. And you can see here how currently right now analog, we actually show 7 or 8 inputs, but there's really a 4-point input channel. That means that you can have 4 voltages and then 4 current inputs to each channel. And currently right now you'll see on my 10 volts I have 5.083 currently reading. So that is my configuration of my Stride I/O modules. So now let's look at our productivity, and under the setup we'll go hardware configuration, and we can see here's my CPU, and we'll look at the Ethernet port, and you can see here that the IP address is 192.168.140. So we'll just hit OK. So that is my configuration of my hardware. So my hardware is actually, this is going to act as the client, which is going out to the servers and grab the information from them each time. So let's look at our program. And our program we've set up in a few different sections. The first one here is my discrete inputs and output communications. Then I have my analog communications. Then I have my main logic to combine the two together and do a few things. So the first one here is my basic communication to my input-output. And during the first scan, or I can start with a switch, or I can when I end my communication for my analog input, I start this again. And what I do is I send, I ask for information out of the Stride digital I/O module, and I'm looking for the system flags, the power up safe modes, and the watchdog timer. So if we go back to our information on the Stride, what we're doing is we have our system flags here at 40011 address, and then we have our power up safe, and we have watchdogs. That's 11, 12, and 13 is the addresses that we're looking for. So again, it starts at address 11. So that'd be 11, 12, and 13 here. So here we're seeing our read flags. So 256 represents the startup bit that we have. This says that we are using the watchdog timer. Then we have our safe mode. So we're actually making sure that all the digital outputs are off when we have a power up or we lose communication. And our watchdog timer is set for 3 seconds. And that is our Modbus read. Next in our program, once we've read that information, we determine whether or not our read flag, bit number 9, which indicates that we have our watchdog enabled, on or not. And what we do is we either we either move a 1 back into the right flags, or we zero it out. So that means that we can control whether or not we have a watchdog timer in our program. Then what we do is we actually write those values into the Modbus information within that card, starting at address 11. So we write our write flags, our power up, and our watchdog timer back in. Then what you'll see is we can, once we do that, then we will read the status of our outputs starting at 31. So our digital outputs, our inputs, our inputs rising latch, our inputs falling latch. Then we're reading our frequency of input 1, 0, 1, 2, and 3, and then our 32-bit counters of input 0, 1, 2, and 3. And we have values here that we can then monitor and see what they are. So as things turn on and off, that's what happens. And you'll notice here on the right hand side, you'll see my flags that I am using, and those flags are used to determine my next step once I've done any errors or any success, and then I go on to the next step and do my next read or write. And after I do that, what I do is then we will write, we'll reset all the, if there's falling or rising edge flags, we reset them. And we reset now so we can use them later on in the program to determine whether or not something turned on or off. Then what we'll do is we will write or set our output relays. So again, once we set our output relays, we write them back into that address, and that will set those output relays for us. And then once we're done that, we will say that our communication has been complete. And then we go on to our analog input card. And when our completion or our communication is complete, then what we will do is then ask for our next card information, which is again the read flags that are on our watchdog timer. And we can see that right here, where we can see that we can look at our system flags and our watchdog timer. Again, 11 and 13. So there's 11, 12, and 13 are what we're reading in. So one of them is blank. Then we can read our input types. Then we can read our analog inputs points on each of the channels that we have. So we'll close that down. And here, again, we're reading our flags. And then what we do is we determine whether or not we're using the watchdog timer, which in this case we are. Then we take that watchdog timer, put it back, or take and set our flag and our timer. Then we write those watchdog timer back in, zeroing out also our error flags, our watchdog bit that comes on, as well as our power up bit that comes on. Then what we do is we read our input types, and then what we do is we then read our analog input signals. And as you can see right now, I have a signal of 5083 representing 5.083 volts coming into that input signal. And then next what we have is our main logic of our controller. So before we go to that, let's look at our actual hardware that we have here. And if we do, right here you can see I have my Productivity 1000 series controller, and we're connected through our Ethernet port right here, both online with our software communicating, as well as communicating over to our Stride units. Here's my digital input output, and here's my analog signal. Again, my output, my first output is connected to my first input as we've shown before. And on my analog, I have my tester here, which I have my battery, 9-volt battery connected through a potentiometer, which goes in here, which tells me a voltage that I'm reading. So what I'll do is, as you can tell, if I take my potentiometer and move it, you can see now the numbers going up, and now we actually have 6.076 volts coming in. So that seems to be working fine. So with that going, what you'll see is we'll look at our main logic of our program. In our main logic, what we have is our watchdog timer. We pick that up. So each time that my watchdog timer times out, I will get a 1 and it will increment my counter value. So let's try that. And this is, I'll unplug the cable. And once I do, what you'll see is my 3 seconds will time up. When that does, we will get a flashing light on our module. And then when we plug it back in, the flashing light will then go solid again as soon as it starts communicating. And then when it does that, what happens is the input of my counter then turns to 2, which you see right here, and it indicates that I have had a situation where I've lost communication to that module. And then further on my program, I can then pick that up. Then I have a power up. So when I lose power to the modules, so if I unplug and lose power to those, you can see I just unplugged the module right now. Both lights are off. As soon as I plug that back in, they will establish communication once again, and it will go up to a 3, indicating that now I've had a situation where I've lost power to my module, and I can detect that within my program. And that's the same thing that will apply to our analog card. And if I remove the analog card input, once again, after 3 seconds, what we have is the light starts to flash, indicating that I've lost communication visually. Then I can plug that back in, and it will go in with a snap. It will establish communication once again, and it will up my count back to the value of 3, indicating that we had a communication lost, and there it is right there, 3. So that works very well. Next, what we do is in our program, we are actually using 2 simple timers and controlling a output of a write. So we have an on delay and off delay. Currently right now, my analog input saying 6074. So we're actually putting this on for 60 seconds and off for 60 seconds. So it's cycling on and off my output. And there's my writing output here. So as I decrease my value, and we can decrease that down to something a little quicker. Let's see, 4 seconds, 3. There we go. So that's a 1.6, so the relays are going on and off a little quicker now. And then finally in my program, what you'll see is I try to determine how quickly I actually am getting a response to the overall system. That means that by the time I turn on or tell the Productivity 1000 to turn on the output, I then measure the input coming back in that says I am now on. And what I do is I set a bit. So I say when I write it, I set the bit on. And when the bit's on, what it will do is calculate or take the number of scans and monitor that scans. Then what I do is take the digital input when I read it, says that it is on. I then move the throughput over and tells me the number of scans it has done since the last time. And then I zero out the previous work area bit. So right now you can see my throughput system scans is currently about 40. It's jumping around, obviously. It's from 30 to 51. And if we go up to, we'll say 30 for example, we go up to setup or CPU, we'll say get CPU scan time. And currently right now we're at 30.2 seconds, or sorry, we're at 1.2 milliseconds. So we multiply that by say 30 or the value in our throughput here, and we will say exactly what the throughput is on our current system for these I/O modules. Okay. And then we can also go to our data view. In our data view, we can actually see everything happening that we have here. So you can see we also have frequency input of our input side, and if we turn that down a little bit more, we can see that frequency will now go up a little bit. And then we have our timers going on and off. We have our actual voltage coming in right now. So a lot of things happening, and we can see the digital inputs and outputs going on. If we want to actually write something more, we could write a, say we'll turn on the other two as well. And we can just write that into there, and you can see that we have two other ones as well that we are now controlling on and off. So if you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us, or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button to get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.